Okay. Hello, everybody. So let us continue with the course overview. So as I mentioned in the last lecture, it's very easy to identify, to locate the the course website. Just in the Google and search my name, and the first one is my link to my homepage, and then you find out there's section teaching, right? And then click this one. We go to the course webpage. I emphasize again because this is very important, because the course website contains all the important information. Of course, Canvas is a platform where we release all the important announcements and information. But if you want to look for some references and more schedules, you should look into the course website. Right? And in the last lecture, we are in the middle of going through the syllabus. So we mentioned that the prerequisites just assume that you know basics of probability theory and statistics, and also you're familiar with linear algebra and vector matrix operations, and have algorithm design and program skills. So if you're not comfortable with the 3 prerequisite terms, let me know. If you have any concerns, let me know. We want you to go through a smooth procedure in this in learning of this class rather than feel painful on that. Oh, by the way, I found many of you have taken this course survey on Canvas, and thanks for those who have done that. So if you haven't done that, please spend like 5 minutes to do that. We really want to know your background, your interest, and your expectation of this class, such that we can adjust the content appropriately for you. And also we have some extra bonus. That's real bonus. So yeah, so please find some time to do that. The more information you provide, the more we'll learn from you. Okay? And also, you may have noticed that we have released the first homework, homework 0. Because we're computer science, we always start from 0 rather than 1. But on the other hand, 0 just means that if you look at, how many of you have a look into the problems of homework 0? How do you feel that? Okay, yeah, I'm happy to yeah. So basically, that homework problems haven't touched any course content we're gonna discuss, especially like machine learning algorithms. They're just some like a basic knowledge review. That homework was created to stimulate you to like sit down and review the basic knowledge you have learned probably several years ago. Like what is random variables, what is expectation, what is rule for probability, how do you compute the probability of union of 2 events, like what is concept convexity. Like if you feel comfortable with that, or if you just okay, I kind of feel not that familiar with that concept, that's okay. I can pick it up easily. That's fine. And but if you feel sick of it, if you're pissed off by those problems, that could be a problem. That could be a problem because those kind of problems we won't cover too much in-depth math in our class. But we do need to know and to be familiar with a few concepts. If you're not familiar with that, or if you do not know most of them, that might be an issue. So in that case, do not hesitate and contact me and talk to me, and we need to discuss. Does it make sense? Yeah. So if you have time, so please start to do it early, because this is the first week, right? So you have the freedom to choose to stay or choose to switch to another class in the first 2 weeks, right? So that's why I released the homework 0 at the very first day of this class, so that you can evaluate whether this is some class worth your efforts, or you need to postpone your plan for this class.
You want us programming Python, basically, right?
I highly encourage you guys to program with Python.
Python indexes from 1, doesn't it? Well, Python's from 0. Never mind.
Oh no, I mean the homework 0. Homework 0 are nothing about Python. Homework 0 is just some mathematical concepts, which assume from, if you're all satisfied, if you're all comfortable with those prerequisite terms, I won't think you have any problem with that. But if you are not comfortable with that, the homework 0 is kind of a test bed. You see whether this kind of problems I feel easy, I feel it's not a big deal. Then that's good. But if you but if you're very sick of that, then it might be a problem. And then to help you better with this class, under that case, please do not hesitate to contact me and talk to me. And any question or any concerns regarding the
So will the homework once forward be counting the final homework or just practice?
Homework what? Homework 1?
0.
home with 0. No, it will be counted toward the final.
It will.
Yeah, it will. Yeah. Any other question? Yeah, if that's the because if you say, oh, it's just practice, then probably no one will do that. So I want everybody to seriously do this and look into these problems, and then you will see, okay, I'm comfortable with that, then they'll probably succeed in this class.
So are we having 5 more or 6 more assignments?
5 more. Yeah. 0, 1, 2, 3, 5, 4. In total 6. Any other question? Okay. So let's continue. In the last lecture we stressed the importance to get help, right? So we mentioned that we plan to offer enough office hours. Every weekday we have office hours. So if you have any questions regarding the course, regarding homework problems, regarding the projects, do not hesitate to come to the office hour. So it's always the face-to-face discussion is always the most effective way to address problems. Of course, if you cannot come, you can post the questions on Canvas, and we will watch the Canvas and try to answer questions as soon as possible, right? And then tentative course outline. So these are just the tentative course outline. So it might be subject to change when we proceed with the class. So basically, our main focus will be on supervised machine learning. So it's a large class of machine learning methods. There is some kind of unsupervised learning and semi-supervised learning. Well, the most important and most widely used type of methods is called supervised machine learning. So why it's called supervised machine learning? So in a nutshell, basically says, okay, it's just like in a classroom, right? In the classroom teach, I'm gonna give you a set of problem examples and tell you the answers. And then you learn how to solve this problem. And next time I present you a new problem with some answers, and then you use the capability you have learned to address that problem. So supervised learning follows the same paradigm. Right? Basically, you present your machine learning algorithm a set of training examples and their labels. Either the image contains the dot or not, or what is the temperature of that day according to the weather, according to the data, right? So, and then you develop machine learning algorithms to find matching from the input data to the label, which is actually answers. And then after this so-called training procedure, when you give your machine learning algorithms some new test example, the algorithm should automatically give you the answer. This is called supervised learning. Okay. So we'll start with the most intuitive supervised learner. It's called decision trees. Why it's called decision trees? Because it's kind of very similar to the procedure human brains make decisions. How does human brain make decisions? We usually work out a set of rules, right? We call it heuristic rules. Like if somebody is very tall, it's not very fat, it might be handsome. Such kind of rules, right? In practice, you use such kind of rules to make decision to predict something. And decision trees actually learns to extract such kind of rules out from data automatically. And they organize those set of rules into a tree structure. Tree structure is very natural, very beautiful structure, very succinct structure. That's the basic idea of the decision trees. And then in the learning of decision trees, we're going to talk about very important concept called overfitting. So you'll see that actually in many cases, if your machine learning model is very complicated, like even if you build up decision trees, if you do not limit the size of the tree, you can allow the trees to be growing arbitrarily deep. are actually right, then no matter how many training examples you fit to your decision trees, it can give you 100% training accuracy. Namely, it can exactly match all the training examples. Is it a good sign? The answer is no. Actually, it's not highly encouraged to let your machine learning algorithms to perfectly fit the training data. That usually indicates that the generalization capability will be much worse. And why? We'll talk about. This is called overfitting issue. And in practice, we need to find all kinds of methods to avoid overfitting. A very commonly used strategy is called cross-validation. Maybe some of you have used that trick before, or you have used that, but you didn't realize that it is used to address the overfitting issue. And then we'll introduce a set of very simple but very powerful ideas. It's called ensemble learning. Basically, you have a set of weak machine learners, but if you can smartly combine them together, it can be combined into very powerful learner or predictor. A typical example is boosting trees and ensemble learning, which includes random forest. And they use decision trees as the base learner, and you learn a lot of decision trees. Each decision tree is very, very small, just one level, and just one or several branches, and you just combine them together. You find it performs really good in practice. Like in the boost, right? In the boost, as mentioned, if you still have an impression, we mentioned that when you use digital camera, the modern digital camera, before you take picture, any human faces appearing in your camera will be bounded, right? It's pretty accurate. It's done by AdaBoost, and everybody is able to implement AdaBoost. And then we'll talk about the classical linear method for machine learning models. It's called linear regression. And if I'm taking the statistics course before, you might have learned that before, right? Linear regression. Just use a linear model to model the mapping from the input to the output. And then we talk about the least mean square approach, a very commonly used approach with global patterns, not only neural nets. Okay, any question regarding the course content?
Are we going to need enhanced processing power? Are these going to be data sets that we can manipulate on our computers, or do we need to use like graphics processing?
GPU?
Computer labs? Yeah.
For homework problems, no. All the data sets you're dealing with are not very large. You do not need to buy NVIDIA and GPU card. It's not necessary. Again, we're trying to learn some underlying ideas and principles of machine learning rather than tune some libraries, right? But if you want to do a project, but even for project, it depends on what kind of project you're going to choose. We'll discuss the details of project later. But again, if you want to use GPU, it's up to your choice, but it's not obligatory. Any other questions or concerns? Okay, so let's talk about the grading policy. Like this is very important, right? This relates to the outcome of this class. So the grading policy, the final grades are integration of the three parts. The first one is homework, which takes 50%. So it's very important for you to finish the homeworks on time. And then a course project. So let me enlarge the set of font. Is it clear for everybody? Even in the last one? Okay, so overall homeworks takes take 50%, and course project takes 30%, and final exam takes 20%. So we don't have midterm exam, and the reason I think taking too much examples make people feel like stressed. I don't like that kind of feelings, because when I were a student, I really don't want to take too many tests. I think whether you're working well is actually reflected in the homeworks, right? And also cross project, because you have to spend a lot of time throughout the whole semester to finish that, rather than you spend like 3 days looking at all materials and you get very high grade. Right? So yeah. So we have 6 homeworks, including homework 0. So after homework 0, we have 5 homework assignments. Right? So the homeworks will consist of both analytical problems and programming assignments. We mentioned it in last class. The programming assignments really require you to implement practical machine learning models and test them in real world or synthetic data sets. So we will give you the data set. So don't worry about the data, but you need to debug your algorithms or models on those data by yourself. You need to make them work. And each homework might have different number of points depending on the work amount. And I'm trying to make each homework to have the equal work amount, but there could be some like deviations. So if you have some worries about that, just let me know. Okay. And you are highly suggested to use MATLAB, Python, or R for the programming portion of the assignments project. I mentioned again, right? It's just want to make your life easier. If you insist on using C++ or Java or Rust or whatever, it's up to your choice. But from my own experience or from many other students' experience, using Python might be the most efficient way, because you don't worry about a lot of like very low level details, right? You can choose any other programming language if you like, but you should guarantee that your programs can be compiled and run on K machines. The reason is that our TA and TMs will grade your homework on K machines. If it cannot be compiled, cannot be executed, we cannot give you grades. So we won't only look at your reports or results. We will test your program. So make sure your program can be carried out on those machines. So your programming assignments, you're free to use existing libraries, especially numerical and computational libraries or optimization libraries, like NumPy and SciPy. Someone asked this question in the last lecture. It's a very good question. Here I want to mention again. Matrix computation optimization, like LBFGS, like conjugate gradient descent, stochastic gradient descent, and those kind of libraries you're free to use, but you're never allowed to call APIs like scikit-learn that directly fulfills the required models and algorithms. Right? If you look into the scikit-learn library, you can create a decision tree by just running one line of code, or just you can create a linear regression model by just running 1 or 2 lines of code. That's not allowed. And also to make the TM and the TA easier to grade or to test your programming assignments, please give a README file and specify how you run. Just one line command. How do you run it? What's the command line to run your script or run your program? So, any question regarding the homework? Both the analytical problem part and the programming assignments.
Where do we submit this?
Canvas. Yeah, you're gonna submit some URLs. So there will be some like .zip file, which includes your source code, which includes your report. Yeah, and then the TM will like extract your files and look into them and grade on them. Any other question? Okay. And then cost project. Oh, one thing I forgot to mention. So you'll see from the homework, especially programming instructions. Every time you will start with creating a GitHub repository. So you will be led to create different folders where you put your decision tree classifiers, your perception, your SVM, and etc. And finally, we hope to say everyone has built your own lightweighted machine learning library. But during your homework, throughout the semester, please don't make your repository public, because I do not want other students to copy your code. It's called plagiarism, right? But after that, you can feel free to make it public, and you can work it. Look, this is my own machine learning library implemented by myself. Does it make sense? Okay, and cost project. So in addition to these homework problems, you have to do some one cost project throughout the semester. So the project aims to use machine learning techniques to address practical problems. Again, for a cost project, you need to create a GitHub repository as well, because we need because it is broken into several milestones. You need to submit several reports, and finally you need to submit all the code. For some exploratory projects, you won't necessary to share your data, but we do need to see our code. We do not want to say someone like fake the data on the final report. That's not allowed. You need to submit midterm final reports, and for details, here's we have one cost web page specify the details about cost project. So now let me explain the details. So say there's a tab. It's project. So I'm trying to put as much details as possible in this page. I think it should be sufficient as a guidance for you to start with the cost project. So basically, let me enlarge the fonts as well. So basically, we have two types of projects. One is called competitive project. So this competitive project is done individually. So you have to do your project. If you choose to do a competitive project, you have to do it by yourself. Okay. So this is essentially a Kaggle computation task, but it's kind of private computation. It's just open to our class. I will share you some link. And if you and we'll provide some data. We'll provide the training data, and you can use all kinds of methods to finish the prediction task, and then submit your test results to the system. And the system will report your current scores, and there will be a ranking on that in real time. So everybody is encouraged to figure out all kinds of methods to improve their ranking, because the top ranked students will be awarded extra bonus points.
Does the ranking affect our grade?
No. But for top ranking students, you will receive extra points. Extra points.
For the Kaggle, would we be just like submitting our kernel or just the predictions? Or like what is the Kaggle competition?
Oh, the test will be a binary classification test. I will release the competition task by this week. So actually, I'm almost done now. But I haven't finished all the details of description of the data sets. But you will see later. Basically, it's a binary classification task, and you have a set of training examples, which include both continuous features, and categorical features, binary features, and you can use whatever methods you want. You can use SVM, you can use logistic regression, you can combine artificial neural nets, you can do feature selection, you can even do some feature combination, whatever. But the goal is to improve your prediction accuracy as much as possible.
Do we use like third-party libraries like
Yeah.
competition?
Yeah. Feel free to use any third-party. Actually, I don't recommend you to use your own implementation because the course project is not the objective of the course project is not to ask you to implement those algorithms. Actually, ask you to utilize the existing machine learning techniques to address practical problems. So the more techniques you are trying to use, the more chance you get better results. So that means you perform better in your project. And the second type of class project is called exploratory project. So basically, if you do not want to attend a competitive project and you have a strong motivation, you have a strong passion to use machine learning to address your own research interest, you can also choose this. The benefit is that you can work on groups, but your group has at most 2 people. So you need to find a group, a team member. And the issue is that you have to identify a problem by yourself. You have to collect and process data by yourself. All things, and the motivation, you need to explain why you want to do that. Right? What's the potential benefit of doing that? You have to explain clearly in the project report. So I encourage most students to do the competitive projects because it's kind of like stimulation, right? Ask you to try all kinds of methods to learn to use all kinds of libraries and look at the feedback and try to improve it by yourself. But if you insist on doing more kind of research or oriented exploration, feel free to do that.
So can students do the second one individually?
Yeah. If you want to do the second one, do it. That you are more than welcome. Any question? Okay. Grading and milestones, right? As we just mentioned, we'll break this course project into several milestones, right? So the very first step, you need to notify the instructor and the TAs what type of project you're going to take, right? And what's the team member. If you take a competitive project, okay, we assume you're individual, right? But if you want to choose the exploratory project, you need to assemble a team as soon as possible. And then the second one is project proposal. For a competitive project, you need to register for the Kaggle competition. You need to have some account in Kaggle. And then I'll send you the link so that you can attend the in-class competition. And you need to make some dummy submission. That's kind of routine, right? And also you should, sorry, I need to move this browser. Oh, sorry. And then you're required to, oh no, you should also submit a Kaggle user to show your identity in the computation. Because we need to map your username to your UID, right? Okay, so for the exploratory project, you need to submit one-page document to answer the following questions. So first, the project team member. Second, what problem do you want to address, right? You need to specify the problem. You need to define your own problem. And also, why it is interesting. Why do you want to use machine learning rather than traditional methods? Right? Why do you think machine learning can see this problem rather than other methods? This is about project proposal. And then by the end of the midterm, which I assume that will be right before the spring break, because I do not want to destroy your spring break, right? So it should be right before the spring break. You need to report. You need to submit the midterm report. And 3-page documents. This is not very messy, right? For a competitive project, you should have made at least 2 non-dummy submissions on Kaggle. That means you have to try at least twice to solve that problem. And you should report what you did and any pre-processing that you need. And please outline your plan for the rest of the semester.
Does twice mean like 2 attempts? Does that mean completely different attempts, or can you develop a solution? Can you just like tweak it and make it different, like make it better, and then have that be your second?
It's not necessary to be completely different. Yeah. It's hard to be completely different, but you can now submit the exact same solution. You should try to improve it. Right? I want to see your efforts in doing this kind of task. Yeah. Any other question? Okay, so there is one bonus here. So by the deadline of the report, midterm report, not including the late days, the top 10 ranked students will receive 3 bonus points. So again, the earlier you start with this, the higher chance you get a bonus.
Like top 10 teams, right? Not students.
Because the competitive project is done individually, so it's top 10, so not top 10 teams. And for an exploratory project that you report should include first what you have done to reach your goal, right? And you can now say, okay, we just collected data. That won't be sufficient. And what is your detailed plan for the rest of the project? You need to think of it thoroughly rather than just very superficially. Right? I will do this. I will do this. You need to think why I would like to do this. Right? Based upon your current results, you think okay, the current model or current methods might need to be improved in terms of what. Then you plan to do what. Make it convincing, right? And also reference to literature. So these are about like intermediate report. Any question? Okay, final report. That will be due by the end of this semester. Right? So the length of final report is up to 6 pages. Right? So I don't worry about that you submit a very short report. I'm just worried that your report is too long, because many students they spend a lot of efforts in doing that. They want to state in very detail. That's very good, but we need to spend some time reading your report. So please be succinct. And 6 pages should be sufficient. And the report should be structured as a small research paper, right? And it should consist of following content. So first, problem definition and motivation. Of course, for the competitive project, you might just rewrite the problem description in the competition page. You don't need to worry too much about this. But for exploratory project, you need to state again what's your definition problem, what's your motivation, right? What is important and interesting, etc. And second, your solution. What you have done to address the problem. Right? For a competitive project, you should state clearly what kind of techniques you have used, how many pipelines you have combined them together, what kind of feature extraction, what kind of data pre-processing procedure you have used. If you conducted cross-validation, how many folds do you use? Right? So what kind of other heuristics or tricks you have found to be useful to achieve your current rank. If you choose to do some theoretical project, I mean, in an exploratory project, well, you just show the proof. That's fine, right? And also experimental results. For a competitive project, well, you just show what's your results, what's your feedback from the system, right? And of course, you can show what is the training performance from your data. That's up to you. And for the exploratory project, you need to design your own metric, right? How do you evaluate the success of your project? What kind of metric do you choose? Why do you choose that metric? Right? Is it simple accuracy? Is it simply an accuracy measure will be sufficient, or you need other metric? You need to state it. So this is more like doing some research project. And finally, it's actually necessary for any research paper. If you have much more time, how will you continue the project, the future work, the future plan? Even if you don't have time to continue, please state some plan. Any question regarding these milestones and
Can you give us an example of an exploratory project? I'm just trying to understand what that might look like.
Yeah. So actually here are a set of examples.
Yeah.
So, but let me give you an example right now. So for example, if I'm a medical, I'm from a medical school, I'm a medical researcher. I'm interested in if some patient needs to do some some operations, like some surgery operations, right? How much blood I need to be prepared. Yeah. So can I build up a machine learning model? Given all the lab results, I can predict how much units that patient needs the blood transfusion. That's one project. Or someone, and nearly every year, their students choose to collect some stock data to predict whether the stock price will goes up or goes down. MIT tells me they never succeed. They never succeed. But anyway, as long as you choose some project, some research project which you think is interesting, you think machine learning is promising, you can do that. Other question? So some students may choose to do the theoretical project. That means the solution and experimental evaluation, as item 2 and 3, will be graded as one component. Right? So if you want to do theoretical project, just let me know. Talk to me. Okay, because the theoretical project really is not very easy. And the final report must include GitHub repository implementation of the project. Right? Again, we're gonna not only look at your final report, we'll also look at your implementation, your code. Probably we'll test your code, probably not. But we need to ensure your code is there. We need to ensure that your report is generated based on some real experiments and results rather than some minor experiments. And experimental evaluations should be rigorous. You should choose fair baselines. You should apply a cross-validation for hyperparameter selection, which we'll explain in detail in our class, and report both positive and negative results. If the results are not promising as you expect, that's fine. That's totally fine. That won't hurt you. That won't decrease your grade. Please be honest to report the results, even if it's negative. Okay. And finally, extra bonus for competitive project. If by deadline of the report, not including ladies again, the top 10 ranked students will receive 7 bonus points. That's at the end of this semester. So if you appear in the top 10 in both midterm and the final term, you'll end up with like 10 bonus points. That's not small. So now let's talk about topics of exploratory projects. If you really want to do some exploratory project but don't have any clue, so here I give you a few examples. Right? So basically, any project using machine learning as a critical step or component will be fine. And if you still want to discuss and look for ideas of possible projects, come to the office hours. And we can brainstorm ideas. Or if you are not sure, you want me to help you to make decision, I'm willing to help. I would love to help. Some examples include like application projects, some machine learning applications that you feel interesting. If you want to reproduce some published results, if you look at some paper, you want to reproduce the results, it's fine. You can do some theoretical project. If you think, okay, I'm interested in some specific conclusion in computational learning theory, I want to extend it, or I want to prove it's wrong, feel free to do that. But be careful to choose that, because surely a theoretical project is not that easy. Algorithmic project, you want to develop a new learning algorithm for a particular type of problems. We will introduce ID3 for decision tree construction. You feel like this algorithm is really bad. I'm sick of it. I want to develop my own version and want to completely beat it. Feel free to do that. And your own research. If you're a PhD student, you're conducting some research project and you think, okay, it worth my class efforts to address that problem using machine learning techniques, feel free to do that. Here are a few detailed examples, like oh, it's already. So it's really hard to operate this. Okay, it looks better, right? I'm going to try to raise it a little bit further. Oops. It's hard. Okay. So last night someone asked me, even do an exploratory report, whether they can choose some past Kaggle computation tasks. That's totally fine. If you look at some Kaggle computation tasks, you found, oh, this is really interesting, but it's already passed. Feel free to do that. So if you click that, this is a Kaggle platform. So it includes tons of the data and applications and problems. And if you're interested in to investigate problems here, feel free to investigate. And there are a lot of data. Some other common examples include like biology and medical study. Can we select genes relevant to some disease, such as breast cancer, Alzheimer's disease? Learning to play board games like Chinese checkers, settlers of Catan, whatever, or StarCraft. Right? And stock market prediction. Detecting sarcasm, humor, irony, metaphor, etc. in text. Sort of cool project. Classify run of a song, book, movie, or painting. Commodity recommendation. Right? Can we use customers' purchase records to recommend commodities to all the new customers? Software security. Can we identify Android apps with malwares? So those are all examples I have. Just examples I collected from students doing in the past classes. This is very cool. It just give you reference, but it's not ask you to must do this kind of things. Right? You are free to choose whatever project you want. Right? Sentimental analysis. Can we classify whether a piece of comment is positive or negative? It's very emotional, or it's very neutral. Spam emails detection. That's all about the course project. Any questions so far? Okay, great. So let's go back to the syllabus.
So just as a general rule, the Exploratory project, in order for us, in order for it to be feasible, there already has to be a lot of available data we can access. As
Yeah.
a general, yeah.
You need to collect data yourself.
Yeah.
Yeah.
Got it.
Yeah, that's some kind of trade-off, right? If you want to give more freedom, you have to deal with more things. Really annoying. So, final exam. So it's open book. So let me move this a little bit. Okay, that looks good. So final exam will be open book. You can bring whatever materials you think that can help exams, but you cannot bring computers, cell phones, tablets that can access the internet. You can bring calculators, that's fine, but you cannot compare other devices. Okay. So I don't want you guys to memorize any formulas. You can print out any slides you want. You can print out all the homework you have done. Just do not use computers, cell phones. Do not post questions on Stack Overchange, or whatever posting, and wait for online help. That's not allowed. Okay. So this is a letter grade metric, right? So because this is a mixed class, right? Mixed class of senior undergrad and grad students. So we're gonna use two different letter mapping. If you take CS 5350 as undergrad students, this is how your numerical grade maps to the letter grade. If you're a grad student, which means you take CS 6350, this is another letter mapping, right? So of course, grad students is required more than undergrad students. So you see the difference from the letter mapping. But in general, as long as you devote your efforts and time in doing these homework problems, you do not miss homework, you do not miss the final exam. It's not very hard to get A minus. Of course, if you want to get A, you should really work hard, right? But as long as you follow the standard procedure, you won't miss the class. You have no problems in understanding course content, and you do all the homework problems. I think a lot of students just will get A minus. And we'll round up your scores to the closest integral values. For example, 90.5 to 90.9 will be treated as 91. Right? But if it's 90.1 to 90.4, it will be treated as truncated to 90. Right? So we don't curve the grade. So you are very well. If after the final exam, someone may feel like if I can have 0.2, I can upgrade it from like a B to A minus, or upgrade it from A minus to A. If you're thirsty about that, you can talk to me. I will try to look at all your homework submissions, or your final exam, and try to find out extra points on that. But if you fail to find that, then that is the final result. You stay where you are. Does it make sense? Any question regarding this part? Okay, so here is the date for final exam. It's on April 24th, but it's 3 months after, so we don't worry about right now. Right? So here is about late policy. So each assignment must be turned in through Canvas by the designated deadline, usually 11:59 p.m. to receive the full credits. Right? So if the deadline is missed, the late submission will have 10% penalty. Right? And then the late submission in every subsequent 24 hours will lose another 10% credit. So, for example, if I have like a 10 points assignment, you will have 2 points penalty if it is submitted 30 hours late, right? Because first you have late submission, second you have exceeded 24 hours. But if the assignment is turned in until the other assignment has been graded or returned or 48 hours after the deadline, you won't have any grade. That means you cannot submit your homework 2 days after the deadline. I usually will not make the exceptions if a student falls ill, unless it is a prolonged illness, and also you can provide a doctor's notes on that. I have made such kind of cases before. I usually suggest students to start the homework as early as possible. Don't rush at the last minute. Especially we have a lot of programming assignments. Sometimes it's like that. If you only have 2 hours, you have to write 200 lines of code, you won't get passed. You always have bugs at that 2 hours. So you need some sufficient time to debug your code. If you believe there's an error in grading homeworks, you may request regrading within 1 week of receiving your grade. Right? So we can look at your grade again, right? But please let us know early, within 1 week. But if you pass 1 week, sorry, we cannot look at your grade. It's fixed. Okay. And you must submit a request to me by emails and explaining clearly why you think your solution is correct. And then I will forward your email to our TM or TA, and they will agree. Does it make sense? Okay. Homework submission. So we all accept homework written with LaTeX, as we mentioned in the last lecture, right? Is LaTeX something that everyone should know for research and writing scientific documents? So I suggest if you have never used them before, try to use it. It's not very hard. It's not that tedious. Actually, as much as you have to deal with mathematical formulas every day, so it's really, really convenient, much more convenient than Word. And here I give you a link. This is a sample text file. You can try to play with that text file, compile, and see what is going on. And along with release of every homework, we'll release the LaTeX template. So it won't be painful for you to. You can directly edit based on the template. And also we will share with you the math template. You use many simplified notations to write down your math formulas, so it won't be that heavy, the workload. Okay. Yeah, we'll release template file, text file along with each homework assignments for convenient editing. And attending final exam. So if you are unable to take the final exam at scheduled time, please contact me ahead, right? And we might be able to schedule another time for you. And if you miss the final exam due to some emergency, please notify me within 3 days of the exam and provide a proof document, like you have to go to the emergency or 911, something like that. Please let me know as soon as possible so that we can schedule a makeup. Okay. And academic policy, those are everybody knows, right? Please read carefully about policy and if a student is caught cheating on homework or test, they will receive a failing grade for the course. So there is some kind of detailed description of the policy. So that doesn't mean I do not allow you to collaborate. Actually, I encourage you to collaborate. How do you collaborate? You can discuss answers with anyone offline, right? And but you have to write your own code proofs and write-ups. You cannot copy others' writing, others' program. That's not allowed. But you can definitely discuss the solutions, but do not post the entire solutions on canvas. That's something we emphasized in the last lecture, right? So if you collaborated with another student such that you expect the answers may look similar, although you two write it individually, right, independently, then you must explain explicitly in the homework submission, right? You can give a comment like, I kind of worry that my homework solution is very similar to someone else, right? The reason is that we haven't discussed before, blah, blah, blah. And then we'll keep an eye on that. Right? If we found some homework submissions like appear to be too similar, and we do not see any such comments, then your submissions may receive 0 grades. So be careful about this part, right? For final exam, yeah, you can look at any materials you bring, but you cannot discuss with anyone, especially except for the instructor or TAs. Right? If you do that, then the exam will result 0 grade. Any questions so far? Okay, and finally, if some physical challenging problem, do not hesitate to let me know beforehand, and we'll try to figure out the way to help you. We have Center for Disability Services, or we can try all kinds of ways to help you. Okay. So as a supplement, I would like to emphasize a few places where might be useful for you guys in the course website. So first, the information tab. So you say again here it's kind of duplicated, but redundant. But it also covers prerequisites and course policies. And if you have time, please take a look at it. And but more useful links are here. Textbooks and linear algebra and probability statistics resources. If you feel uncomfortable about some mathematical content we discussed in the class and you want to review them, here are a set of links. If you want to know more in depth about machine learning and other techniques, you can look at those books as well. But those books are all very thick, and I suggest you to read them as a dictionary rather than read through it, unless you have enough time. Yeah. Here are linear algebra resources. This link is written by some guy who graduated from MIT. It's very good resources to operate, to conduct derivatives with respect to matrix and vectors. That will be very useful if you want to do some thorough study in machine learning, because in machine learning world we actually deal with everything. Only deal with matrix and vectors. We usually don't consider scalar steps. Right? And Matrix Cookbook is not a very popular book, and basically it's just like dictionary. When you take the gradient with respect to some matrices or vectors, you just copy the formulas and apply the chain rule. That's it. Linear algebra review and references. This is from Standard course and Stanford course. The linear algebra chapter, deep learning book written by Ian Goodfellow and Evangel. Linear algebra lectures in MIT. Those are very good resources. So if you feel unclear about something, do not hesitate and look into those resources and refresh your mind. Okay, and some links to the probability and the statistics resources as well. And so here's the topics. This is actually overlapped with the syllabus. I think the most useful tab will be this lecture page. So I will release the lecture slides right before the each lecture. I'm sorry that today I didn't release it because we actually share the same lecture slides with Tuesday. But anyway, I will release the lecture slides before every lecture after all. And you can click the link here to download the slides, this PDF. And also, I will also release the link to the YouTube video. So this is the link to the last lecture video. So because the lecture here is streamed to the YouTube data science channel. It's a U of U data channel in real time. So after I finish the lecture, when I go back, return to my office, I will find the link and then share it in the house web page. So if you want to review the lectures, or if you don't have time to attend lecture, but later you want to watch the video, you can find this web page and click the video. And also you can download the lecture slides. So I think that will be very useful. And also when the homework assignments are released and then due, it will also be released here. Okay? Yeah. Now we have finished all the course overview, right? It's kind of messy, but I really want to give you a general idea, the requirements, and to help you have a high level impression about this course organization and help you to make a decision. As I mentioned, right, this course is about the underlying concept and algorithmic ideas about machine learning. It's not about learning some specific tools, and the workload is pretty heavy. And it's quite challenging. You need to plan on enough time, on average 20 hours per week to do this work. So again, please be cautious when you make decisions. But if you commit to do that, please try your best to do that. And we're always here to help you. Okay, so we'll see you on next Tuesday.